Hello everyone, welcome to today's class. This is Teacher Simon taking you through Cambridge International AS and A-Level Mathematics for May, June 2024, paper 42 for questions 1 to 4. Question 1, a cyclist and bicycle have a total mass of 72 kilograms. The cyclist rides along a horizontal road against a total resistance force of 28 newtons. Find the total work done by the cyclist to increase his speed from 8 meters per second to 16 meters per second while traveling a distance of 100 meters. In my sketch here, I'm going to represent this as the cyclist. So he's going this side, that means has the driving force. And then here there is resistance to motion, which is 28 newtons. And of course, the speed here is 8 meters per second. Then this cyclist maybe reaches here, and the final speed here is 16 meters per second. Okay, and the distance, they have told us that it is 100 meters that he moves in here. Now, since there is speed here, so that means we have kinetic energy. And also here we have kinetic energy. We don't have potential energy. I'm going to use the energy method, or also the other one using forces, and then the equations of motion. So here, we don't have potential energy because we are on the horizontal road. Okay. Now, we say work done by the driving force, work done by the driving force, then minus work done against resistance, work done against resistance, work done against resistance, then this one is equal to the change in mechanical energy, the change in mechanical energy. And for mechanical energy, this one is potential energy plus kinetic energy. Kinetic energy is a half mv squared, but kinetic energy is a half mv squared, and then potential energy is mgh. But potential energy, we don't have it, so that means the change in mechanical energy is due to the change in kinetic energy. Now, work done by the driving force is the one that we are looking for, because they said find the total work done by the cyclist to increase his speed from this to that. Okay. Now, work done by the resistance force, we have gotten this 28, but it is going to cover this distance of 100 meters. So we shall have 28 then times 100, because you know that work done is equal to force times distance. And then change in mechanical energy, we are going to get the final kinetic energy, which is the mass here is 72, so a half times 72, and then the velocity is 16 squared. Then we subtract a half times 72, and then times this one is 8 here squared. Okay, so that means work done by the driving force is going to be equal to what we are having this side is a half of 72 is 36, right? And then we have 16 squared here, which is 256. And then we also have this, this one is common, okay? And whatever is happening, you just now put in the calculator to get the values. So here we have 8 squared. Then I can bring this one this side, then it becomes plus, then that's 28,000. So then what do we get as the work done by the driving force? Getting this in my calculator, I have 36 into 16 squared minus 8 squared, then plus 2800. What do we get? 9712. So it is 9712 joules. Okay, work is in joules. Alternatively, I said you can use the one of forces and also the equations of motion. So I can use v squared, which is equal to u squared plus 2as, and then my f, which is equal to ma. Okay, now I can get the acceleration here because we are given the final speed and the initial speed and also the distance traveled. So that means acceleration is going to be v squared, and the final is 16, then squared minus the initial, which is 8 squared, then I divide by 2 times the distance traveled, 100. So putting this in the calculator, we have 16. We are going to have 16 squared, then minus 8 squared, then we divide by 200. Then this one gives us 0.96. So our acceleration is 0.96. After getting acceleration here as 0.96 meters per second squared, then I'm going to substitute it here. Okay. Now, when this particle is going forward, the net force that takes it forward is the driving force, okay, then minus the resistance force, which is 28, and then the mass here is given as 72 kilograms. So we shall put 72 here, then times our acceleration, which we have gotten as 0.96. So meaning the driving force here is going to be this 28, then plus the 72 multiplied by 0.96. So what do we get altogether? So this 0.96 then times 72, we get that answer there, then plus 28. So altogether it gives us 9712. So 9712 newtons. That is the driving force. Then work done by this driving force. Okay, work done by this driving force is going to be this force here times the distance traveled, and the distance traveled is 100. So you see that we get the same answer, 9712, okay, joules. As simple as that. Question 2. A particle moves in a straight line at time t seconds after leaving a point O on the line. P has velocity v meters per second, where v is equal to 40 minus 60 squared minus 36. Now here we are given the expression of the velocity. That means we cannot use the other three equations of motion. V is equal to u plus at, s is equal to ut plus a half at squared, and also v squared is equal to u squared plus 2as. We cannot use it. Okay, so now here we use differentiation and integration because we are given the what? The expression. This is what we call variable acceleration. Okay, for the others, the acceleration is constant. Now, acceleration is the rate of change of velocity. So that means acceleration is equal to dv dt. Okay, so differentiating this one, we shall get 44, then minus 12t. Okay, and then they are saying that find a set of values of t for which the acceleration of the particle is positive. So if the acceleration of the particle is positive, then that means we shall say this one is greater than 0. Anything positive has to be greater than 0. That means we shall have negative 12t here, then greater than, you take this 44 this side, it becomes a minus. So minus 44. Then from there, we are going to divide all through by negative 12. And then when you divide all through by the negative, you have to change the inequality sign. So we shall have negative, less than the 44 over 12. This one can be simplified to, by 4, we get 11. Then by 4 down, we get 3. So our answer can be this one. In fact, we can write it like this. 0 less than t less than 11 out of 3. Because time cannot be a negative. So that means it is above the 0, and then it will be less than 11 over 3. So any of these two you put is correct. Then part B, find the two values of t at which p returns to O. When p returns to O, that means displacement is 0. Okay? When p returns to O, displacement is equal to 0. Displacement is equal to 0. Now, if velocity is the rate of change of displacement, that means displacement is going to be the integral of v with respect to t. So our s is going to be the integral of the expression of v. It was given as 44t minus 6t squared, 44t minus 6t squared minus 36. Okay, we integrate this with respect to the t, and you know that we increase the power by 1, so we shall have 44 t squared, then over 2. We increase the power by 1, then we divide by the new powers. This is 6t cubed over 3, and then here we have 36t, then plus an arbitrary constant c, because we don't know the constant that disappeared when they differentiated, because you know that when you differentiate a constant, it always disappears. So our s here is going to be equal to 22t squared minus 2t cubed, then minus 36t, then plus c. However, at t is equal to 0, when it is beginning to move, at t is equal to 0, they are beginning at that point. So that means s is 0. So when I put everything in here, that simply implies that our c is also going to be equal to 0. So the expression for displacement is 22t squared, then minus 2t cubed minus 36t, just like that. Okay, but then they told us that we are supposed to find the two values at which p returns to O. And I've said that when p returns to O, displacement is 0. So I will equate this one to 0. In fact, let me write in decreasing powers of t. So negative 2t cubed, then plus 22t squared minus 36t is equal to 0. I can factorize out the negative t, the negative 2. By the way, even t is common everywhere. So that means here we shall get t squared, and then here we shall get minus 11 of t, and then here we shall then have a plus, okay, 18, which is equal to 0. What is inside here in the brackets is a quadratic. So two numbers, when I multiply them, I get 18, but when I add them, I get negative 11. That has to be negative 9 and negative 2, not so? So that means we shall have negative 2t, then t minus 2, and then t minus 9, which is equal to 0, meaning when I equate all of these ones to 0, I can get t is equal to 2 as one of the values, and also t is equal to 9 as one of the values, but there is also t is equal to 0. But they told us here that find the two values of t at which p returns to 0. So already at t is equal to 0, it is at that point. Okay, so after 2 seconds, it is coming back. Probably it was like this. This was the point O. So it moved. Then after 2 seconds, it is back here. 2 seconds. Then it goes, maybe it comes back after 9 seconds. When they have elapsed, it is back here. So that is what we are having there. So we are not going to write t is equal to 0, because they said when it returns, okay? So those are the two values, t is equal to 2 and t is equal to 9. Question 3, 4 coplanar forces of magnitude p newtons, 10 newtons, 16 newtons, and 2 newtons act at a point in the directions shown in the diagram. It is given that forces are in equilibrium. If the forces are in equilibrium, that means the resultant in x is 0, and also the resultant in y is 0. So if you have been following me, we have always said that when you close, it's a cosine. So here we shall have 10 cosine of that 25. Then when you open it, it is going to be a sine. Okay, so let's resolve all of these forces. And usually I always draw all the forces in one diagram that is smart. You can pick a leaf and you also start doing that. So I can draw something here like this. We have to resolve forces horizontally and also vertically. Now, when you look at what is up here, the forces that are on these vertical and horizontal axes, you leave them. So here there is P. Now, when I resolve this one here, it will be facing here, okay? So we are going to have here 10 cos of 25. Then we shall have here 10 sine of 25, okay? Then I will go to this one here, close it. So when I close it, it is going to give me 16 cos of theta. Then I will open it up. Opening is sine, closing is cos, right? So we are going now to have 16 here. Let me expand it here. 16 sine of theta. And then when I close this one here, it is going to be a cosine. So I will have 2 cos of 40. And then I will open it here. It will be 2 sine. So we have 2 sine of 40. 2 sine of 40. So those are our forces there. Now, since the system is in equilibrium, that means resolving forces horizontally, what is going this way is equal to what is going this way. Okay? So we can put 16 sine theta, 16 sine theta plus 2 cosine of 40. Then this one will give us 10 cos of 25 degrees. Okay? Then after that, I can actually find theta from here. So theta is going to be the arc sine of, here we have 10 cosine of 25. Then first take this on this side, it becomes a minus, right? So it will be minus 2 cosine of 40. Then after that, we shall divide by 16. Then we shall be remaining with sine theta. Then from there, we take the arc sine, okay? So putting this in the calculator, we get, you have the arc sine. Then up there, we have 10 cos 25. Then minus 2 cos 40. Down, we have 16. And the answer becomes 28.07 whatever. But then to 1 decimal place, theta is going to be equal to 28.1. That is to 1 decimal place. Remember, angles, we round off to 1 decimal place. Then how about looking at forces vertically? So we shall have here P is the only force that goes up. Then is going to be equal to whatever is going down, 2 sine of 40. Then plus 10 sine of 25. And then we also have 16 cos of theta. Okay? So here, putting everything in the calculator, P is going to be, now I'm going to say 16, I will just say cos of theta. So put cos of the answer we have gotten, okay? And then we shall put 16 there, okay? 16 cos of the answer we have gotten. What do we get? We get that figure, then plus 10 sine 25, and then plus 2 sine of 40. Just exact. So that means P is going to be 19.6 to 3 significant figures. 19.6 newtons, okay, to 3 significant figures. Question 4. A car has mass 1,400 kilograms. When the speed of the car is v meters per second, the magnitude of the resistance to motion is kv squared newtons, where k is a constant. Then part A, the car moves at a constant speed of 24 meters per second up a hill inclined at an angle of alpha to the horizontal, where sine alpha is equal to 0.12. At this speed, the magnitude of the resistance to motion is 480 newtons. Part 1, find the value of k. Now, to find the value of k, first of all, they have said that the resistance is given by this, okay? And the speed is 24 meters per second. So that means I will get this kv squared. I will just substitute the v as 24 squared. Then this one I equate to the 480, which is given here, okay? That means our k is going to be equal to 480. We divide by 24 squared. So what is the value of k here? Putting this in the calculator, 480, then divide by 24 squared. This one gives us 5/6. So I will write 5 over 6 there. You leave it exact. Don't write your three significant figures. Roman 2, find the power of the car's engine. Now, I'm having, again here you can use the work energy method, or you can use the forces. So there's driving force, and since it is going up, then the resistance is acting downwards, which is kV squared. Okay, remember they said has the magnitude of the resistance to motion is this one. Then this part is under this. So meaning we have that resistance to motion. But again, on an inclined plane, we should know that there is mg sine theta. Okay, mg sine alpha, which is always acting downwards. Now, they said somewhere that this is a constant speed. So for constant speed, then acceleration is 0. For constant speed, acceleration is always equal to 0. Now, using our F, which is equal to ma, so the driving force here, then we subtract the forces that are opposing the motion. We have 480, then minus mg. M is 1400, the g is 10, then sine of alpha, was it given as, it was given as 0.12. So 0.12, then this is equivalent to 1400, okay? Of course, times 0. That is 0, acceleration is 0. So meaning the driving force is going to be equal to 480, okay? Then when we get 1400 times 10, then times 0.12, that one gives us 1680. So plus 1680. When we add these, what do we get? Plus 480. That one gives us 2160. So 2160 newtons. Now, power is equal to FV, right? The driving force, then times the V. So the driving force is 2160 times the speed. The speed is constant here, which is 24. So times 24. Then what do we get? Times 24. This one gives us 51840 watts. So that is that. Then part B, the car now moves at a constant speed. Constant speed. We should know that acceleration is what? 0. On a straight level ground. Now we have this car here on a straight level ground. Okay? Straight level ground. So we have the driving force taking it forward. Then we have the resistance to motion. Remember, it is kV squared, but our K is 5 over 6 V squared. And then they are telling us that given that its engine is working at 54 kilowatts, find this speed. Remember, F is equal to ma. So we have the driving force here. Now minus the resistance force, 5 over 6, okay? V squared, which V we don't know, that we are looking for. Then this one is going to be equal to 0 because acceleration is 0, okay? So meaning the new driving force here is going to be equal to the resistance force. By the way, if a particle is moving at constant speed, the resistance force is always equal to that driving force because acceleration is 0. So you can easily see that this one, when it comes here, the acceleration, the driving force is equal to the resistance force. But we also know that power is equal to that driving force, then times this that velocity or the speed. Then, meaning the driving force here is going to be equal to the power, which is 54,000. You are supposed to use watts, not kilowatts. Then divide by that speed, you see? So this simply implies that we shall have 54,000, then divide by the V, then we shall equate to 5 over 6 V squared. When I cross multiply, I'll just bring the 6 here. It multiplies with 54000. and then I will get here 5, then v cubed. So for me to get v, it will be the cube root, okay, of 6 times 54000 divided by 5. So altogether, what do we get? You put cube root of 6 times 54000, then you divide by the 5. So we get 40.2 to 3 significant figures. So V is equal to 40.2 meters per second. That is to 3 significant figures. So that has been it for this first part of the paper. Thank you so much for watching. May God bless you. If you find the content very helpful to you, kindly like, share, and even subscribe. See you in the next videos.